Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing questions based on atoms and molecules, atomic mass, molecular mass, mole concept, determination of chemical formulas. Now question number 46 I am discussing. Up to 45 already I have discussed. Now I am telling the question, you have to answer it. First, that is question number 46. Choose the correct statement. You have to choose correct statement. The use of 12C scale has superseded the older scale of atomic mass based on oxygen 16 isotope. An important advantage of the former being: first, the atomic masses on carbon 12 scale became whole number. Option 2, carbon 12 is more abundant in the Earth's crust than oxygen 16. Third, the difference between the physical and chemical atomic masses got narrowed down significantly. And fourth option, 12C is situated midway between metals and non-metals in the periodic table. Again I am reading the question. The use of, you have to select correct statement. Remember, what is the statement? I am telling you. The use of 12C scale has superseded the older scale of atomic mass based on oxygen 16 isotope. One important advantage of the former being: first, option first, the atomic masses on carbon 12 scale became whole number. Second, option second, carbon 12 is more abundant in the earth crust than oxygen 16. Third option, the difference between the physical and chemical atomic masses got narrowed. The differences between physical and chemical atomic masses got narrowed down significantly. And last option is carbon 12 is situated midway between metals and non-metals in the periodic table. You have to choose the correct statement. Just you think it is very easy. Now correct statement is: the difference between the physical and chemical atomic masses got narrowed down significantly. Means option C is correct. Option C is correct. Why? Now I am telling you. physical atomic weight are obtained by taking mass of oxygen 16 isotopes as 16.000050 16.000000 chemical atomic weight obtained by taking the average mass of the natural mixtures of oxygen isotopes as 16.00000. This is also 50. Knowing the mixture of oxygen isotopes, knowing the percentage occurrence of 3 isotopes of oxygen, means oxygen 16, oxygen 17, oxygen 18. The true mass is actually found to be 16.00447. This is the actually true you can say true mass is actually found to be by after taking average of 3, 16, oxygen 16, oxygen 17, oxygen 18. The true mass is actually found to be 16.00447. Taking C12 as the reference, the benefit I am taking, that taking C12 as the reference, difference between the two narrowed down. Okay, taking C12 as the reference, the difference between the two narrowed down. Now next question is question number 47. The isotopes of chlorine with mass number 35 and 37 are exist in the ratio of, again I am reading the question, the isotopes of chlorine with mass number 35 and 36 exist in the ratio of, first option is 1:1, second option is 2:1, third option is 3:1, fourth option is 3:2. Again, one more time question I am telling you. The isotopes of chlorine with mass number 35 and 37 exist in the ratio of option 1, 1:1, option 2, 2:1, option 3, 3:1, option 4, 3:2. Tell me the correct answer. It is very easy. Answer is 3:1. Option third option means option C. Okay. Now this is based on observed facts. This is based on observed fact. Okay. 3:1 means 35 isotopes of chlorine with mass number 35 and 36. 35 is found more than 37. Okay, chlorine 35 is found 3 times more than isotope 37. This is based on fact. Now next question is, that is a question number 48. The correct value of Avogadro number is First option is 6.02 into 10 to the power 21. Second option is 6.02 into 10 to the power 22. Third option is 6.0 into 10 to the power 23. And option 4, 6.62 into 10 to the power minus 34. It is very easy. You can answer it within 10 seconds. Correct answer is option C, 6.022 into 10 to the power 23. Here option given 6.02 into 10 to the power 23, but exactly 6.022 into 10 to the power 23. It is well known. Okay. Now this I told you about the correct value of Avogadro number. Okay. Now next question, that is the 49. Question number 49. Which one of the following statement is incorrect? Incorrect, not correct. Okay. You have to tell the which one of the following statement is incorrect. First I am talking, first option is 1 gram atom of carbon contains Avogadro number of atoms. Second option is 1 mole of oxygen gas contains Avogadro number of molecules. Option third, 1 mole of hydrogen contains Avogadro number of atoms. And last option is 1 mole of electrons stands for 6.02 into 10 to the power 23 electron. Okay. This again I am telling one more time. Which one of the following statement is incorrect? Wrong. First statement is 1 gram atom of carbon contains 1 gram atom of carbon contains Avogadro number of atoms. Second option is 1 mole of oxygen contains Avogadro number of molecule. Option third, 1 mole of hydrogen contains Avogadro's number of atoms. And fourth option is 1 mole of electrons stands for 6.02 into 10 to the power 23 electrons. This is also very easy, but all are important what I am discussing now. Then here option third, that is the option C, that is wrong. 1 mole of hydrogen contains Avogadro's number of atoms. This statement is wrong, means option C is correct. This statement is actually wrong, but answer is this only. Option C is correct. All are all statement except these, except option 3, all 3 are correct statement. Only this statement is wrong. Option C. Hence correct answer is C. Okay. And here 1 mole of hydrogen atoms. 1 mole of hydrogen atoms contain Avogadro's number of atoms. This is the this you should know. It should be 1 mole of hydrogen. 1 mole of hydrogen atoms should be, not only hydrogen. Not only hydrogen atoms. 1 mole of hydrogen atoms contains Avogadro's number of atoms, not only hydrogen. Here a statement was 1 mole of hydrogen contains Avogadro's number of atoms. That's why it is wrong. Now next question is question number 50. 49 I told you, now 50. Question number 50. 1 mole of oxygen. 1 mole of oxygen gas is the volume of, 4 options are there. First option, 1 liter of oxygen at STP. 1 liter of oxygen at STP. Option 2, 32 liter of oxygen at STP. Option 3, 22.4 liter of oxygen at STP. Option 4, 6.02 into 10 to the power 23 molecules of oxygen at any temperature and pressure. Again I am telling one more time question. 1 mole of oxygen gas. 1 mole of oxygen gas is the volume. It is asking volume, about volume. 1 mole of oxygen gas is the volume of 1 liter of oxygen at STP. This is the first option. Second, 32 liter of oxygen at STP. Third option is 22.4 liter of oxygen at STP. And fourth option is 6.02 into 10 to the power 23 molecules of oxygen at any temperature and pressure. Then it is well known that 22.4 liter of oxygen at STP. This is the correct answer. Means 1 mole of oxygen gas is the volume of 22.4 liter of oxygen at STP. Okay. This is based on definition of mole. Okay. Next question, that is question number 51. 5.6 liter of a gas at NTP, normal temperature and pressure. Okay. 5.6 liter of a gas at NTP are found to have mass of 11 gram. The molecular mass of the gas is, 4 options are there. First option is 22. Second option is 44. Third option is 88. Fourth option is 32. Which one is correct? Very easy. 30 seconds maximum. It will take below 30 seconds time. Again I am reading the question. 5.6 liter of a gas at NTP are found to have a mass of 11 gram. 5.6 liter of a gas at NTP are found to have a mass of 11 gram. The molecular mass of the gas is, first option 22, second option 44, third option 88, fourth option 32. Then it is very easy. Just to think, just you know that a very means you can understand 22.4 liter is equal to 1 mole, that you know, and 1 mole means molecular mass. Then 5.6 liter mass is 11 gram. Then what will be the value for 22.4 liter? Just you have to multiply by 4, means 11 into 4, 44. Option of second option is correct, means option B is correct. 11 into 4, 44. Okay, because 5.6 into 4, that will be 22.4. Hence correct answer is option B, that is the 44. Okay, this I think it is clear. Molecular mass is the 22.4 liter of the gas at NTP. Now next question, that is the question number 52. The number of atoms of oxygen present in 10.6 gram of Na2CO3 will be. Here you can take 1 minute time. First understand the question. After reading the question, only for answer I am telling you 1 minute time maximum. Then here again I am reading the question. The number of atoms of oxygen present in 10.6 gram of Na2CO3 will be. First option is 6.02 into 10 to the power 22. Second option 12.04 into 10 to the power 22. Option third 1.806 into 10 to the power 23. And option D, fourth option, 31.6. Just to think, hardly 1 minute time, less than 1 minute. Okay, remember 10.6 gram of NO2CO3. In this NO2CO3, oxygen is there. Then the number of atoms of oxygen you have to calculate. You have to find out. Then that you can do very easily. For that, you have to calculate molecular mass of Na2CO3, that is equal to 1 mole. Correct? Then Na2CO3, what will be the molecular mass? Actually, its correct answer I will tell you first to solve it. Then Na2CO3, it's a molecular mass. First you have to calculate. Okay, and what will be the molecular mass? Then here 10.6 gram of Na2CO3, then that will be actually equal to 0.1 mole. 0.1 mole. Just to calculate, then it will come 106. Molecular mass will come 106. Na2 means 23 into 2 plus 12 plus 48. 3 oxygens are there. 48. Then 48 plus 12, 60. 60 plus 46, 106. Then 106 means 1 mole. Then value is given 10.6, means 1/10, means 0.1 mole. Then 0.1 mole means Avogadro number divided by 10. Or you can tell 0.1 mole is there, and then 1 mole is equal to 6.022 into 10 to the power 23. Then 0.1 into Avogadro number means 10 will go, means 10 to the power 20 will be there. But here in 1 mole 3 atoms of oxygen are there. In 1 mole Na2CO3, 3 oxygen atom is there, and simply you multiply. That will be 3 into Avogadro, 3 into 6.02 into 10 to the power 22. This is for 0.1 mole, 10.6. Hence 3 into 6, it will come 18, you know. Then that's why its a correct answer will be, that is option 3. 1 point, that 18 you can write in term of 1.8 also. Then 22 will become 23. That is a 22, but you want to write in the term of 23. That is given in the question. Answer is given in term of 23. Then 18 you can write 1.8. Means it will come, it will come 1.806 into 10 to the power 23. Option 3 is correct answer. C, option C is correct. And one more question I want to discuss now. I am reading the question number 53. Which of the following has the largest number of atoms? Which of the following has the largest number of atoms? First option is 0.5 gram atom of copper. Second option is 0.635 gram of copper. Third option is 0.225 mole of copper. And option D, fourth option D, that is a 6.35 into 10 to the power 20 AMU of copper. Fourth option is 6.35 into 10 to the power 20 AMU of copper. Again, one more time, question I am telling you. Which one of the following has the largest number of atoms? Largest number of atoms. First option is 0.5 gram atom of copper, 0.5. Second option is 0.635 gram of copper. Third option is 0.25 mole of copper. And fourth option is 6.35 into 10 to the power 20 AMU of copper. This will take more than 1 minute, one and a half minute it will take time to calculate. Okay, because little calculation is there, not too much, but it is, you have to calculate. Then you start with 4 options are there. For each given option, all you have to calculate, then usually you can do. Okay, first option is a 0.5 gram atom of copper. Then 0.5 gram atom of copper means what? 0.5 gram atom of copper means 1 by 2 means half into Avogadro number. You know that Avogadro number is equal to 1 mole. 1 mole, and 1 mole is actually gram atom. 1 gram atom means 1 mole. Hence half gram atom means half mole. Hence half mole means half Avogadro number divided by half. That will come 3.01 into 10 to the power 23 atoms. Okay. Now second option they have given 0.635 gram copper. Then now you know that 63.5 gram means that is the molecular mass. 63.5 gram is equal to 1 mole. You know molecular mass of copper is 63.5. Given mass is 0.635 gram. It is a gram, not gram atom. Only gram copper is written. Not they have written gram atom. If gram atom means mole, 1 mole. But here is a gram copper, not atom. They have written simply 0.635 gram copper. Then how many moles? You divide it by molecular weight. Then 0.635 divided by 63.5. That will be 0.01 mole. And then 0.01 mole means 6 point, you have to just 0.01, 1 upon 100 mole. 1 upon 100 mole means from the 23 it will come 21. means 6.02 into 10 to the power 21 atoms. Okay. Now third option is given 0.25 mole of copper, means 1/4 mole of copper. Then again Avogadro number is equal to 1 mole. Then Avogadro number divided by 4, means its value will come 6.0 divided by 4, means 1.50 into 10 to the power 23 atoms. Correct? And last option is 63.5 AMU of copper. 63.5 AMU of copper means 1 atom of copper. 63.5 AMU copper means 1 atom of copper, means 6.35 into 10 to the power 20 AMU of copper is equal to how much? Just this number you divide by 63.5. Okay, because this is the copper, its a molecular mass is copper atomic mass is 63.5. 63.5 is atomic mass, you remember. Then this 63.5 AMU that you divide by 63.5, then you will get 10 to the power 19 atoms. 19 atoms. Then now you have calculated, then now it is easy for you to select the option. Then just you see largest number, you have to find out largest number of atoms. Then you have calculated for all option number of atoms you have calculated. Then by seeing the value you can tell that option 1 3.01 into 10 to the power 23 atom is largest, because other three are, one is 6.02 into 10 to the power 21, it is less, and 0.25 means 1.50 into 23, 1.50. First one was 3.01. Both are 23, but that is 3.01, first one, and this is the 1.5. Hence, this also can't be the answer. Okay, and last option, its value is coming under the 10 to the power 19 atoms. 19, that is also not correct. It means less only. Hence, correct option is A, option A, first option. Okay, then I have discussed now total 53 question. Now I am stopping only here. Next class again I will continue. Thank you.